Hello, my name is Jeremy Helgevold. This is my submission for GPE104 Project 3. The character art and animation info I got from opengameart.org from user Antifaria, and the remainder of the art I got from opengameart.org from user Hyptosis. Alright, on to the rubric. First item is canvas screen space. So as you can see, the game is called Ninja Looter. It starts with this UI, main menu, that lets you click play, male, female, or quit. That is a canvas item, and it is in screen space. Next item is canvas world space. So each enemy unit has a canvas item as a child, and it is set to world space, and it contains exclamation points, or an exclamation point, question mark, and a UI element that fills, that is used to indicate to the player that they're about to turn in the direction of the sound that they thought they just heard. So all those are using world space. Next item is canvas scaling. So this main menu, as well as all the menu not gameplay UI elements, use this black background, which is just a raw image that has been scaled. It is anchored to the middle and stretched, so it's just been scaled to be just a separator between the game world and the UI information. Canvas text object, right here. Every one of these menu items, the main menu, the game over, and the you win menus all have a text object that has information, or just pretty much flavor text on them. Canvas image object, the both on the main menu, or the menu UIs, the title and the headers are, like Ninja Looter here, is an image. It's just set to the game title image, and in each enemy, as I said, in their canvas, there's an exclamation point image, a question, and then this filled image that just shows a progress bar. Canvas button object. Yeah, so the main menu has a play button and a quit button, as well as toggles for male or female gender of your player. And the game over menu has return to main menu, quit, and the win menu also has return to main menu and quit. Game Manager uses FSM for game state. So my Game Manager is here, and it has a coroutine called Game FSM that is initiated on startup of the Game Manager, and it tracks 3 states in an enum, which are set to menu, active, and game over. So they're in a menu, they're in active gameplay, or they're in a game over state. And the coroutine, the Final State Machine coroutine, is always going, and it switches between the menu, the game over, and the active states. So the menu state is pretty much just waiting for you to press a button. The active state just pretty much lets the camera know it needs to follow the player, and then is relied upon for other game code to run its logic. And then the game over will determine if you won or if you lost, and then it'll enable the correct UI elements. Artificial Intelligent Finite State Machine. Alright, so that is controlled by my enemy controller. Similar to my Game Manager, it uses a coroutine, and this one's called Enemy AI FSM, and it uses an enum for its states as well, and it has idle, patrol, and looking. And the Final State Machine, similar to the Game Manager, just switches between idle, patrol, and looking. And it switches between them within themselves, and there's also other functions that can alter the state of the enemy AI, and this looks for those as well. AI hearing check for noise. Alright, so the way noise works is the player controller, when they're moving, uses a physics 2D overlap circle, and the radius is based on the current sound level of the player, which is settable in the editor, and it gets all of the player pawns within that circle and calls a listen function and passes it the location of the noise and the sound level. And then the enemy listener script, which is really simple, it's just on any enemy, takes that distance and location and determines using vector3.distance if the enemy can hear it, and then it sets a couple of variables that the AI will use, the finite state machine will use to switch its state to looking. The next one is vector3.distance. Okay, yep, I use that right here to check to see if the noise was actually something they can hear. The next item is AI vision. So vision is controlled in the game by a circle collider on each enemy. There's a radius 1 circle collider, and anything in that, when that collider overlaps with a player, the enemy watcher script that I have will use a raycast to fire a ray at that player location to see if there's anything obscuring its vision to it. If not, it will then do a vector3 angle check between the direction the player is from the enemy and the direction the enemy is currently looking. And if it's if it's within the angle that is settable in the editor, it will tell the game manager that the player has been spotted and to proceed to the game over state. All right, the next item is vector3.angle. So yeah, right here, vector3.angle is used to tell if the player is within a view angle in front of the enemy. Next item is physics2d.raycast. Yeah, so right here, physics2d.raycast is used to make sure that the player is not obscured from vision, and I do that doing a layer mask on each enemy. It's just obstacles and player, so if it hits an obstacle, obviously it can't see the player, and if it hits the player, obviously it can see the player. Next item is controller parent class. So my controller parent class is just called controller. It's an abstract class. It just holds a reference to the current pawn that it's controlling and a reference to the game manager, and it sets those in its start function. And then, okay, the next is AI controller and player controller. So both the enemy controller, which has all the enemy finite state machine logic, is a controller, and the player controller, which has much less logic, just movement, and the make noise function, also is just a controller. All right, next one, pawn parent class. So my pawn class is a abstract class. It contains everything that a controllable entity needs as far as movement, which is here. It just moves along a direction and orients the direction. It has logic in here that assists with the animation state machine that is in Unity's animation system, so it just controls a lot of the booleans that dictate how the character is animated in that system. So that's the parent pawn class. Next item is bug error free. Okay, so pretty much the only way I know how to show this is play the game and show that the console is clear. Alright, so you start the game, Ninja Looter, the game where you steal our heroes' hard-earned loot. You can play, you can select male, female, or you can quit. I'll select female and hit play. So now you can move around. The current collection of items that you need to win the game is listed up here. Oh, and I just lost because I ran in front of that guy. So return to main menu, play again. So you can collect items. I just collected that gold. I'm going to go collect these supplies. Walking around avoiding the enemies. Collect those supplies. I'll walk in here. I'll trigger his... Oh, he thought he heard something. He's about to turn around. He looks. I'm not in the circle, so he didn't spot me. I'll avoid this guy. I'll make some noise. Grabbed his loot from behind him. He looks around, can't see me. So I'm at 4 of 17. I can go grab these 3. Oh, she saw me. So return to main menu. I will set the game manager count to win to 1 to show the win condition. So that I just need to play and go collect one thing. And the win comes up. Can return to main menu and quit, return, and then I can play again. All with no errors. Alright, comments. All my code is pretty heavily commented. My game manager, all of the variables are commented, what they do. The state machine has each line what it does, commented. The root pawn class, everything's commented what each function does, what each line does. Controller, it's very small, but comments what each thing is. Same with the enemy controller, the finite state machine for the enemy. Says what each state does, what the things inside each state do. Player controller, my standard movement code, says what each one does. And the noise generator function says what each item does. And the player pawn just has its info for what it does when its colliders work. Enemy pawn, same deal. This is just the extra logic to draw that circle around them so that the user knows the distance they need to keep. It's just a line renderer. Enemy watcher, very simple. The code is commented. Enemy listener, the code's commented, and the thing on that is on everything you can collect, just a couple lines, and it's commented. Project organization. So there's a lot of stuff with this project, but in the game world itself, I have my game manager, which has just as a child the spawn location of the player, the main camera, the player controller itself, which is always at 0, 0, 0. This doesn't move. The pawn moves. The level boundaries I put in its own little thing, just in case I wanted to make a level that kind of sprawls a little more than just a square or a rectangle. But all these walls with the boundaries, colliders are in there. All the collectibles I just collected when I set the level up. I just pulled them into this folder. All the obstacles, the rocks, the walls, same deal with that when I set up the level. All the enemies are in here. The 10 enemies, the roam are in there. The ground, the grass, and then the little rocks that you can walk over that are scattered around. Just pulled them in there. The event system that runs the UI, and then I have my menu UI items, which are game over, game win, and main menu, and then my gameplay UI, which is the just the tracker for how many collectibles you pulled. So that's the in-game organization, and then the asset organizations. I have my animations set up by each individual character, so each one has a male and female version, so I have animations for those set up in the animations folder. The art, same deal, characters, collectibles, ground, obstacles, UI, walls, and the prefabs are set up pretty much the exact same way to make it easy to build levels. Scenes, I just have the main scene and scripts, just those few scripts. So that's my project organization. The last item is game exceeds minimum requirements. So I did a good bit extra here, especially on the enemies. I found these cool like fantasy trope sprites that I really liked on Open Game Art, so I just decided to set them all up to be able to animate and move around because the script, the individual sprite sheets were provided by the artist. So in the I used Unity's animation system, which is pretty much a finite state machine as well, to control if they're moving right, left, up, and down, to play specific animations, which are just they're just cycles of 3 sprites that just rotate. So if I pick, so this is the healer, so they have the female healer, that is, just has these healer animations for right, up, down, and then the idle animation, which is just a single frame that just loops if they're just sitting still, not moving. So I did that for all of the different enemy types so that they could all move and animate like they do in the game. Yeah, I also put in collectibles. The sprite pack kind of prompted me for the overall game, because it has all these fantasy tropes like warrior and priest and mage, and then they also included a ninja, which I thought kind of stood out. So I just figured I'll make a game where the ninja is the player and all the normal heroes are wandering around trying to protect the loot that they've got in their various adventures, and then you just try to collect it from them without being spotted to kind of follow the stealth, sneaky requirement of the assignment. I also put various obstacles in that block vision. I also put in this extra ground object, these rocks, and what that does is increases the sound you make, so they will hear you from farther away. So right now you can go in kind of really close to them if you're not in front, before you'll make a noise that they can hear, and then they'll turn. But if you run over the rocks, that greatly increases your sound, and that can be adjusted on the character itself, like the where is it? Right here, the or maybe it's on the controller. Well, it's settable in the UI somewhere where you can yeah, right here, sound multiplier. So for both the player characters, the ninja male and female, you can set the sound multiplier to whatever to adjust how much sound you make if you run over a ground object that is marked as a loud ground object. So that was fun to play with. Yeah, I think those are the main things. All the animation stuff with their finite state machines built in, and the different mechanics of the sound level detection implementation, and of course the choosing of the gender choosing I thought was pretty cool, since it gave us two. You can just choose your gender and it'll pick the gender of the ninja that you want to play as. Oops. Yep. Okay, that's my submission for this one. Thanks for listening, and I'll see you in the next one. Bye.